Alright, let's look a little bit more at the formula for standard deviation and try to figure out what exactly it's doing. We said that we want standard deviation to basically be how spread out the distribution is. So we're going to try to build it up from scratch and see where that formula comes from. Just as a side note, this is not going to be a very mathematical video. Later on, I have another video that explains from a math standpoint why the formula we wrote down is the correct one. But for this video, we're just going to kind of go intuitive like we're a scientist or something. How would we try to measure how spread out data was? So let's start with the most simple thing in the world, point distribution. So all of your data is equal to the mean. Here's the mean, and we have all these data points, and they're all equal to the mean. Alright, well, I think it's intuitively clear if we're measuring how spread out something should be, this distribution is not spread out at all. So whatever standard deviation is going to be, the standard deviation of a point distribution had better be 0. Alright, well, let's start tweaking with it. So let's say we have something that looks like, here's our mean, we've got a couple points here, a couple more here, just kind of drawing a little frequency diagram, a couple points over here, points there. Okay, I guess I'm going to make it symmetric just to make the picture a little easier. And maybe a couple points that are actually equal to the mean. Well, let's think about trying to talk about the whole thing, how spread out it is, by building it up one point at a time. Well, these 2 points right here, again, because they're equal to the mean, they're not going to give us any spread at all. If I look at the ones just to either side, I should count these somehow as being a little bit of spread. And let me change colors. Maybe that'll help. If I count the ones to either side of them, I should count these as a little more spread. And these guys that are further away, I should count as a big amount of spread. So we haven't really gotten anywhere yet, but we've already figured out something. We figured out how we should build the whole thing. First of all, we should look at one point at a time. Secondly, things that are close to the mean should give a very small contribution to how spread out the distribution is. Things that are further away should give a bigger contribution to how spread out it is. So it seems like whatever our formula is going to be, it needs to involve, well, take every point and see how far it is from the mean. Now, if we just say, okay, well, let's just take these differences, x minus mu, and average them. So average them, we add them up, divide by how many they are. Here we've got a problem. If we do this, we're going to get 0. For a very simple reason. If we just take the differences like this, well, if we take one of these points on the right minus the mean, these all give positive numbers. So all these over here will give positive numbers. On the other hand, if we take the guys here on the left, when we subtract this guy minus the mean, which is bigger than him, it'll give us a negative number. And because the mean's in the middle, if you take all these negative numbers, well, they're pretty much going to cancel out the positive numbers. That's what it means for the mean to be in the middle. So if we're going to do this, the first thing we need to do is somehow make all of these numbers positive. So our first step is to make all the numbers positive. All right, let's see if I might need to start my page over. It's starting to get a little messy. Okay, let's kind of redraw this guy. Here's my mean. I've got a couple points here. 1, 2, 3. 1, 2, 1, 2, 3, 4. 1, 2, 3. Oh, yeah, 1, 2, 1, 2, 3, 4. All right. So let's try making the thing positive. The easiest thing to do would just be, instead of averaging the x minus mu's, let's average the absolute value of the x minus mu's. And let me go ahead and write down the other alternative, the one we actually went with in the official definition of standard deviation. Instead of averaging the absolute values, we average the squares. Our question is, why is this better than this? Let's think about it for a little bit. If I were to average these, the ones on the inside give a smaller contribution than the ones on the outside, but it's not really enough smaller. I want to say if I cut off my entire distribution, so I just have this part, I mean, who knows, maybe these that aren't on the mean, that's just experimental error. I don't want to count that as being just very, very far from the mean. On the other hand, if I take these on the outside, these are definitely away from the mean. So I want to count things that are far away more heavily than I want to count the things on the inside. If I just take the absolute value, this counts all the points with the same weight. I mean, of course, if I take one of these, the distance is smaller, so this absolute value of x minus mu isn't as big, but we're still giving it just as much consideration. If I put the squared in it, it basically counts a particular distance with a weight that's proportional to that distance. But let me just say it's with its high weight, the bigger it gets. So these points on the outside, not only do they have bigger contributions to the standard deviations, they also have a bigger say on the standard deviation. It's like they get more votes. So their vote by itself is bigger, and they get more votes. So that's what this squaring does. All right. And again, why is that an appealing thing? If there's small errors, that could be experimental error. The big things, I mean, those are definitely there. So we want those to have the biggest influence on our formula. So that's kind of an intuitive idea where this comes from. Again, this is not the mathematical version. In the math version, it actually winds up being very simple, and I'll make another video about that. But in the math version, the sigma is basically the distance between the distribution we start with and a uniform distribution, viewed as points in Rn. So I'll make another video that walks through this version, but if you just want to go intuitive and don't want to think about, like 27-dimensional space and stuff like that, that's really all the standard deviation is. You're averaging how far you are from the mean, and you're giving more votes to the points that are further from the mean.